Every year, Americans pay trillions of dollars in taxes with the expectation that the money will build roads, schools, hospitals, and the infrastructure that keeps the country running. Sometimes it does, and sometimes it disappears into projects that never work, never finish, or cost taxpayers billions more than anyone promised. A high-speed railway that ballooned from tens of billions to well over $100 billion before carrying a single passenger.
This is fantastic news for American taxpayers and for California taxpayers, as the high-speed rail project is the biggest public infrastructure failure in United States history. The estimated total cost has ballooned from $33 billion to $128 billion. And even the New York Times found that it's not on pace to be finished this century.
A subway station that became one of the most expensive transportation projects on Earth. Across the United States, these aren't isolated mistakes. They're some of the largest public works projects ever attempted, built with good intentions, ambitious promises, and taxpayer money. But somewhere along the way, budgets exploded, deadlines slipped by years, and costs kept climbing long after the original plans had been forgotten. The question isn't whether governments should build big projects, it's why so many of them become so much bigger and so much more expensive than anyone expected. Today, we're counting down some of the biggest taxpayer-funded megaprojects that went spectacularly over budget, revealing how billions of public dollars were spent, what went wrong, and whether taxpayers ever got what they were promised. Let's begin with the biggest one of them all. In November 2008, California voters approved a bond measure with a promise attached: build the first true high-speed rail system in the United States. Connect San Francisco and Los Angeles with trains traveling at 220 miles per hour. Move passengers between the two cities in 2 hours and 40 minutes. Faster than flying when you factor in airports. The cost, voters were told, would be approximately $33 billion. The trains would be running by 2020. Californians voted yes. That was 18 years ago. The project is notoriously over budget. According to the 2024 Project Update Report and subsequent business plans, the full Phase 1 cost from San Francisco to Los Angeles is projected at between $88 and $128 billion. Still 3 to 4 times what voters were promised, and still without a single mile of high-speed track in operation. The project's own peer review group chair has publicly described the current trajectory in dire terms. A state senator stood before the legislature and said what most people had been thinking for years. This is a project that will never be built, and everybody in this building knows it. What happened between the ballot measure and that statement is one of the most studied infrastructure failures in modern American history, and the answer is not one thing. It is everything, compounding simultaneously. California's proposed route crossed some of the most legally contested land in the country. Thousands of individual property acquisitions required years of court proceedings each. Every section of the railway needed its own environmental review, and those reviews invited legal challenges, which triggered more reviews. The route through the Tehachapi Mountains alone required tunneling work so technically demanding that no contractor alive had built anything quite like it. Then there are the contracts. As of November 2025, the project had issued 597 change orders, costing more than $2.3 billion above agreed prices. Nearly 7% of the original total budget spent entirely on paperwork adjustments to agreements that had already been signed. The federal government lost patience. The Federal Railroad Administration terminated $4 billion in unspent federal funding, citing over 16 years of delays with not a single mile of high-speed track laid. The only visible progress exists in California's Central Valley, concrete viaducts rising above farmland between Merced and Bakersfield, a segment connecting two mid-sized cities that nobody needed a 220-mile-per-hour train to reach. The earliest projected opening for even the reduced Central Valley segment is now 2033. Full Phase 1 completion, under current plans, is listed as sometime in the 2040s, if the funding materializes, which it currently does not. That is more than 3 decades after voters approved the original bond. The California High-Speed Rail Project began as a vision of the future and became something else. Proof that a project can be too big to stop and too far along to cancel, burning money at both ends while the trains exist only in renderings. For more than 40 years, a highway ran straight through the middle of Boston. The Central Artery, elevated 6 lanes above downtown, was built in the 1950s to carry 75,000 vehicles a day. By the 1980s, it was carrying nearly 200,000. Rush hour started before dawn and didn't end until after dark. The accident rate on that stretch of road was 4 times the national average. Engineers weren't talking about widening it anymore. They were warning that it might fall down. The solution was unlike anything attempted in an American city before or since. Move the highway underground, not reroute it, not replace it with a new elevated structure. Dig a new interstate directly beneath the existing one while keeping the existing one running above, while Boston operated normally around and through the whole thing. In 1982, planners estimated this would cost $2.6 billion. Construction began in 1991. What engineers found beneath Boston was a century and a half of infrastructure layered on top of itself, most of it never accurately mapped. Sewer lines, gas mains, electrical conduits, abandoned tunnels, building foundations from the 1800s, all occupying the space where workers now needed to build a modern interstate. The city could not stop to let them work. Nearly 200,000 vehicles still needed to move through Boston every single day. So contractors built temporary steel support systems to carry the weight of the existing elevated highway, while workers excavated beneath it. They dug beneath active subway tunnels while trains ran overhead. They worked in spaces so tight that entire sections of highway had to be shifted laterally multiple times, so a new tunnel could be slid into the space the old one had just left. The engineering was extraordinary. The management was not. By the late 1990s, it was already clear the project had a concrete problem, literally. Massachusetts State Police raided the offices of the Big Dig's largest concrete supplier and seized evidence that substandard material had been poured into sections of the tunnel. Over 200 complaints were filed by the state for leaks, quality violations, and safety failures. The project's own director was fired in 2000 after failing to disclose $1.4 billion in overruns. Then came the night of July 10, 2006. Milena Del Valle, 39 years old, was riding with her husband through a Big Dig tunnel on the way to Logan Airport. At 11:01 p.m., 20 anchor bolts in the ceiling failed simultaneously. A concrete panel measuring 20 by 40 feet, weighing 26 tons, detached from the roof and fell directly onto their car. Her husband survived. She did not. Federal investigators spent a year reconstructing what happened. The root cause was a catastrophic failure of communication and oversight across multiple parties. The epoxy manufacturer, Powers Fasteners, had not clearly distinguished between its standard and fast-set formulas in its marketing materials. Project engineers incorrectly assumed both versions were rated for long-term sustained loads, such as permanently hanging concrete ceiling panels. In fact, only one was. The result was an epoxy that was never designed for the sustained static weight it was asked to bear, installed in a safety-critical application without anyone catching the distinction in time. 20 anchor bolts had pulled free of the tunnel ceiling in the moments before the panel fell. The cost to inspect and repair similar anchor systems throughout the entire tunnel network, $54 million. The settlement paid by the Construction Management Consortium, $450 million. The settlement paid to Milena Del Valle's family, $28 million, drawn from 15 different defendants. The Big Dig officially completed in 2007. Final construction cost, $14.8 billion. With interest on borrowed money, total public cost reached approximately $22 billion. The original estimate had been $2.6 billion. It did work. The elevated highway came down, and where it had stood, casting shadows over neighborhoods for 5 decades, the city planted the Rose Kennedy Greenway, parks and gardens stretching through the urban core. The Zakim Bridge, wide and elegant across the Charles River, became one of the most photographed structures in New England. Traffic improved. Boston was transformed. It just paid 9 times what it was told it would. New Yorkers were first promised a subway under 2nd Avenue in 1929. That year, city planners approved a massive expansion of the transit network. The 2nd Avenue line would run the full length of Manhattan's East Side, carrying hundreds of thousands of passengers daily and relieving the crushing overcrowding on the Lexington Avenue line, already the busiest rail corridor in the Western Hemisphere. To make room for the new subway, the city demolished the elevated rail lines that had run along 2nd and 3rd Avenues, confident the underground replacement was imminent. The elevated lines came down in 1942 and 1955. The subway they were demolished for didn't open until 2017, 97 years after it was first proposed. In the decades between those two dates, the 2nd Avenue subway was approved, funded, canceled, and restarted so many times that New Yorkers stopped counting. Construction actually began in 1972 and was halted in 1975 when New York City nearly went bankrupt. The stub tunnels built during that attempt sat beneath the street for 30 years with no trains inside them. When work finally restarted in 2007, the MTA said Phase 1, 3 stations on the Upper East Side, 1.8 miles of tunnel, would cost $3.8 billion and open by 2012. It opened in December 2016. Final cost, $4.45 billion, making it the most expensive subway ever built on a per-mile basis anywhere on Earth at the time of its construction. For context, similar projects in Italy, Sweden, Spain, and Turkey cost 8 to 12 times less per mile. The entire 8.5-mile 2nd Avenue line, when completed across all 4 phases, is now projected to cost more than $17 billion. Why? The explanations are structural and arguably unfixable without fundamentally changing how New York builds. Union rules required contractors to pay $450,000 per tunnel boring machine used. Safety and permitting requirements for utility relocations, of which there were hundreds beneath Midtown Manhattan, added months and tens of millions per block. Station platforms were built 100% longer than the trains that would ever use them, leaving empty space at each end that passengers cannot access, but that still required full excavation and finishing at full price. The MTA's internal cost estimation process has been documented to bake in a 40% contingency at the earliest planning stage, a cushion that in practice becomes a floor rather than a ceiling. Phase 2 of the 2nd Avenue subway has faced significant funding uncertainty. In mid-2024, the MTA's capital program was severely disrupted by the indefinite suspension of the Manhattan Congestion Pricing Program, which had been a primary funding source for expansion projects. This threw the timeline for Phase 2 into serious doubt. Under current planning, Phase 2, extending 1.5 miles to 125th Street, carries an estimated cost approaching $7 billion. Phases 3 and 4, which would extend the line down to Houston Street and then to Lower Manhattan, have no funded completion timeline. Under the most optimistic scenario, the full 8.5-mile line would be finished sometime around 2050, 120 years after the elevated trains were torn down to make way for it. The island of Oahu is 25 miles wide at its widest point. Nearly 1 million people live on it. There are essentially 2 north-south highways serving the entire population, and when one of them slows, which it does, every day, the other fills immediately. City planners had talked about building a rail system since 1967. When they finally committed to it in 2008, the promise was specific: a 20-mile elevated metro connecting West Oahu to downtown Honolulu and Ala Moana. Fully automated trains, no drivers, service every few minutes, cost $5.1 billion, opening 2020. Construction began in 2011. The first serious problem was the ground, not what was in it, but what it meant. A Hawaii Supreme Court ruling in 2012 determined that the project should not have moved forward without a complete archaeological survey of the route, which crossed land containing native Hawaiian burial sites. Construction halted for over a year while the survey was completed. When bidding resumed, prices had jumped 14%. The second problem was the Pacific Ocean. Almost every major construction material, steel, specialized equipment, prefabricated concrete, had to be shipped to Hawaii across thousands of miles of open water. When global shipping costs spiked, the project felt it directly. There was no alternate supplier around the corner. The third problem was the management. The state auditor's report described the Honolulu Authority for Rapid Transportation as an agency that was overpromising, under-delivering, noting that Hart had awarded nearly $2 billion in contracts without first achieving the construction milestones those contracts required. U.S. Department of Justice subpoenas followed. Federal funding was withheld. The original 20-mile route was shortened to 18.5 miles. 2 stations were eliminated, all of it designed to bring the official cost estimate down to a number that would unlock additional federal funding. As of today, the first 10.75 miles of the system operate between West Oahu and Central Oahu. The segment connecting to the airport, downtown Honolulu, and Ala Moana, the destinations that made the project worth building, remains under construction. Full completion is projected for 2031, 11 years past the original promise, at a final cost that has climbed to over $12 billion against the original $5.1 billion estimate. The trains run. The guideways stretch across Oahu's southern coast in the cleanest, most modern-looking elevated rail infrastructure in America. But as of today, Skyline terminates at Halawa, near Aloha Stadium. For a commuter trying to get from West Oahu to a job downtown, the rail saves time on one end of the journey and then requires a bus or rideshare for the rest. The full promise of the project remains undelivered more than a decade after construction began. Every weekday morning, hundreds of thousands of Long Island commuters pour into Penn Station on Manhattan's West Side. For as long as that system has existed, the commuters whose offices sit on the east side of Midtown have had to get off at Penn and walk, transfer, or take a cab. The solution seemed straightforward. Run Long Island Railroad trains under the East River and directly into Grand Central Terminal. Space had been reserved for it since the 1960s. Engineers had kept the lower levels of the 63rd Street Tunnel vacant for decades, waiting for this connection. In 2001, the Metropolitan Transportation Authority announced it was ready to build. Estimated cost, $3.5 billion. Opening, 2009. It opened in January 2023. The final bill, $11.6 billion in direct costs, with debt service closer to $12.6 billion. When the $4 billion in supporting infrastructure is counted honestly, the total approaches $16 billion. The tunneling cost alone worked out to approximately $8.8 billion per mile. For comparison, London's Crossrail, which bored entirely new tunnels beneath one of the densest cities in the world, cost roughly $3 billion per mile. New York spent nearly 3 times as much for infrastructure far less extensive. The new station beneath Grand Central is genuinely remarkable. 8 tracks, 4 platforms, 140 feet underground, connecting to street level by some of the longest escalators in the city. Tens of thousands of commuters use it every day and save up to 40 minutes on their round trips. The system works. The question that has followed East Side Access since the day it opened is not whether it was worth building. It is whether it should have cost $11 billion to build 2 miles of commuter rail, and whether the same forces that produced that price tag will make every future attempt to improve American transit equally impossible. Transit researchers have spent years trying to understand why New York's numbers diverge so sharply from the rest of the world. Their conclusion is not a single cause, but a system of interlocking factors. Excessive station sizes, labor rules that pay workers for tasks they don't perform, fragmented project management across dozens of agencies, safety regulations that are individually defensible but collectively paralyzing, and utility relocation processes that can take years for a single block. Together, they produced a project that cost 3 times what a comparable tunnel would cost in London and nearly 9 times what it would cost in Madrid. East Side Access is not an anomaly, it is a mirror. The Washington Metro is one of the finest subway systems in the United States. What it was never designed to do is connect the Maryland suburbs to each other. Getting from Bethesda to Silver Spring, from College Park to New Carrollton, from any one Maryland metro station to any other, requires going through downtown Washington. The detour adds 20, 30, sometimes 40 minutes to journeys that should take 10. The Purple Line was designed to fix this. Light rail running east-west across Montgomery and Prince George's counties, connecting 4 metro branches, 3 marquee commuter lines, and creating the first direct Maryland-to-Maryland rail link in the Washington region. When Maryland approved it in 2013, the estimated cost was $5.6 billion, and trains were expected to carry passengers by 2022. Construction began in 2017. The first legal challenge arrived almost immediately. Community groups argued the environmental review hadn't adequately studied declining metro ridership and its effects on Purple Line projections. Courts agreed additional review was needed, adding months to the schedule and millions to the cost before a single station was finished. Then, in 2020, the entire contractor consortium walked off the job. The companies building the Purple Line announced they were withdrawing, citing years of delays, utility conflicts, and conditions that made the original contract impossible to execute. For nearly 2 years, construction stopped. Partially built bridges stood over empty roads. Station platforms waited without tracks. Heavy equipment sat idle, while lawyers determined who would pay for what. Maryland settled for hundreds of millions of dollars, hired new contractors, and restarted in 2022. By then, inflation had rewritten every estimate. Steel prices had spiked more than 40% in some categories between 2020 and 2022. Concrete costs rose substantially. Labor shortages drove up wages. Total cost climbed to nearly $10 billion, nearly double the original figure. The Purple Line is still under construction. When it opens, it will carry an estimated 60,000 passengers a day and transform commuting across an entire region in ways that are genuinely needed and long overdue. It will also have cost twice what taxpayers were promised, not because of engineering failure, but because of lawsuits, contractor collapse, inflation, and the compounding financial punishment of delay. Denver International Airport was designed to be unlike any airport built before it, covering more than 53 square miles. Larger than the island of Manhattan, it would have runway space, terminal capacity, and passenger flow that no other American airport could match. At the center of that vision was a technology that the city called the most sophisticated baggage handling system ever attempted. Across more than 21 miles of underground track, thousands of individual carts would race between terminals at up to 17 miles per hour, automatically routing every suitcase from check-in to aircraft without a single human hand touching it. A computer would track every bag in real time. The lost bag problem that every frequent flyer knew would be eliminated. The company hired to build it, BAE Automated Systems, warned from the beginning that the timeline was impossible. The system required at least 4 years. The city was giving them 21 months. 3 separate companies submitted bids, and all 3 said the same thing: not enough time. The city rejected all 3 bids and went to BAE directly. BAE agreed to try. They were still trying on April 27, 1994, when airport officials invited reporters and television cameras to watch a live demonstration. The carts began moving. Then they began crashing. Some flew off the tracks entirely. Suitcases were flung from moving carts at speed, some disappearing under conveyor belts, some splitting open and scattering clothing across the track network. Cameras captured carts accelerating into corners and slamming into equipment. A computer error sent dozens of bags to the wrong concourse simultaneously. The footage was broadcast around the world overnight. Denver's baggage system became synonymous with technological overconfidence before the airport had carried a single passenger. Engineers spent months rewriting software. Equipment was replaced, but the more they modified the system, the more complex it became. The airport maintained an empty building at a cost of approximately $1.1 million a day while repairs continued, a total delay bill of around $560 million. Denver International finally opened in February 1995, 16 months behind schedule. The automated baggage system operated in a single concourse for a single airline on outbound flights only. The rest of the airport used the conventional manual system. By 2005, United Airlines shut down the remaining automated equipment. Maintaining it had become more expensive than loading bags by hand. Miles of track and thousands of carts sat unused beneath the terminals for years until they were dismantled and removed piece by piece. The airport itself became one of the busiest in the world, exactly as planned. Its unusual tent-like roof, made of white Teflon-coated fiberglass, became one of the most recognizable airport structures in America. The vision for the airport worked. The vision for the technology inside it did not. What the Denver baggage system left behind was not just a $560 million overrun and a collection of dismantled hardware. It left behind a case study taught in virtually every project management and engineering program in the country. Don't build technology you haven't finished designing. Don't compress a 4-year timeline into 21 months. Don't ignore warnings from 3 separate contractors. The technology that was supposed to eliminate human labor from baggage handling was itself replaced by human labor. The future, in this case, turned out to be people with carts. Somewhere in America right now, there are 90,000 metric tons of spent nuclear fuel sitting in temporary storage at reactor sites in more than 30 states, in cooling pools and concrete casks designed for short-term use. The waste from 60 years of nuclear power generation waits for somewhere permanent to go. That place was supposed to be Nevada. In 1987, Congress studied more than a dozen potential sites for a permanent underground repository. One by one, political opposition from host states eliminated the alternatives. Nevada had the least political clout in Washington. Congress passed what became known informally as the Screw Nevada Bill, the Nuclear Waste Policy Amendments Act, eliminating every other candidate and designating Yucca Mountain, a volcanic ridge 100 miles northwest of Las Vegas, as the nation's sole permanent nuclear repository. Nevada was not consulted. Nevada's governor vetoed it. Congress overrode the veto. What followed was one of the largest scientific investigations ever conducted for any civil engineering project. Between 1987 and 2009, the Department of Energy drilled hundreds of boreholes, collected thousands of geological samples, studied groundwater movement, mapped fault lines, and analyzed how volcanic rock would behave over 10,000 years. Engineers bored a 5-mile exploratory tunnel through the mountain's center, not for storage, just for study, at a cost of more than $1 billion by itself. Inside that tunnel, scientists found evidence that raised significant questions. Traces of radioactive chlorine-36 associated with atmospheric nuclear testing in the 1950s appeared in rock samples at the repository level. This suggested water might be able to travel from the surface to that depth far faster than safety models had assumed. The finding triggered a major scientific controversy in the late 1990s and 2000s. Subsequent independent audits and studies raised doubts about whether the samples had been contaminated during the drilling process itself, and experts debated whether the rapid water transport models were overstated. The science was genuinely unsettled, a source of uncertainty, though not the definitive knockout blow it was sometimes portrayed as. What did kill the project was politics. Senator Harry Reid, by then Senate Majority Leader, made defeating Yucca Mountain a personal mission that stretched across his entire career. Nevada filed more than 200 separate legal challenges against the project. In 2009, the Obama administration cut funding. 800 project employees were laid off. Work stopped. The tunnels remained. The surface facilities remained. And the 90,000 metric tons of nuclear waste scattered across the country remained exactly where it had always been. By the time of shutdown, between $9 and $15 billion had been spent on Yucca Mountain, depending on what you count. Nuclear utilities sued the government for breach of contract and recovered more than $8.6 billion in settlements, with total federal liability projected at $39 billion. Not a single container of commercial nuclear waste has ever been placed inside the mountain. The waste continues to accumulate, roughly 2,000 metric tons per year, in temporary storage at facilities that were designed as interim solutions while a permanent repository was built. Some of that storage sits at the sites of nuclear plants that have since shut down entirely. The storage has now been temporary for over 40 years. 9. Seattle had a highway problem and an earthquake problem, and they were the same problem. The Alaskan Way Viaduct, a double-deck elevated highway running along Seattle's waterfront, carried 100,000 vehicles a day when a magnitude 6.8 earthquake struck western Washington in February 2001. The structure survived, but engineering inspections afterward found cracked columns and weakened supports. Another major quake, and sections might not hold. The city debated for years before choosing the most ambitious option, a 1.7-mile bored tunnel beneath downtown Seattle, replacing the elevated highway and returning the waterfront to the city for the first time in 60 years. At the center of the plan was a machine that had never existed before. Named Bertha, after Seattle's first female mayor, the tunnel boring machine was built specifically for this project by Hitachi Zosen in Osaka, Japan. At 57.5 feet in diameter, she was the largest tunnel boring machine ever built at the time. She began digging in July 2013. She was supposed to finish in December 2015. On December 6, 2013, 4 months and roughly 1,000 feet into a 9,270-foot journey, Bertha stopped. The main bearing assembly had overheated and suffered catastrophic damage. She could not move forward and could not be repaired underground. The only solution was to excavate a 120-foot pit from the surface of downtown Seattle, lift Bertha's 2,000-ton cutter head out through the pit, repair it at street level, and lower it back in. The repair took almost 2 years. During that time, engineers identified what had likely triggered the failure. An 8-inch steel pipe, installed in 2002 by the highway project's own research crews to measure groundwater levels, had been left in the ground and was not accurately recorded on the engineering drawings. Bertha had struck it. The legal dispute over who bore responsibility, the contractor or the state that left the pipe, took years to resolve. Bertha completed the tunnel in April 2017. The SR-99 tunnel opened to traffic in February 2019, more than 3 years behind schedule. Total cost, $3.3 billion. The Alaskan Way Viaduct was demolished. Seattle's waterfront opened to public space for the first time in generations. Bertha's components were scrapped afterward. The Port of Seattle kept a 20-ton piece of the cutting head as a memento. In the summer of 1993, beneath the plains of Ellis County, Texas, 14 miles of tunnel had been bored through Austin chalk limestone. 17 access shafts connected those tunnels to the surface. Buildings sat on 16,000 acres of acquired land. Thousands of workers had spent 2 years constructing what was supposed to become the most powerful scientific instrument ever built. Then Congress voted to cancel it. The superconducting supercollider was conceived in the mid-1980s as America's decisive move in the race to understand the universe. Physicists had been hunting for the Higgs boson, the particle that gives other particles their mass, for decades. Finding it required smashing particles together at energies no existing accelerator could achieve. The SSC would solve that. A circular tunnel, 54 miles around, equipped with 10,000 superconducting magnets cooled to temperatures colder than outer space. Ronald Reagan approved it in 1987. Texas won the right to host it over 25 competing states. The original estimate, $4.4 billion. Construction began in 1991. Costs started climbing almost immediately. A decision to increase the magnet aperture by 1 centimeter, made to improve the collider's performance, added 30% to the project's cost in a single revision. By early 1993, the estimate had reached $8 billion. By fall, $11 billion. The Cold War had ended, and Congress was cutting spending everywhere. On October 21, 1993, the House voted to cancel it. $2 billion had been spent. 14 miles of tunnel sat beneath Texas with no machine inside. The facilities were sold off piecemeal, the tunnels filled with groundwater. The surface infrastructure deteriorated behind chain-link fences. Meanwhile, CERN built its own particle collider in Switzerland, but not in a tunnel dug specifically for it. CERN had spent billions constructing a 27-kilometer tunnel in the 1980s for a previous experiment, the Large Electron Positron Collider. When LEP finished its mission, CERN reused that existing tunnel for the Large Hadron Collider, avoiding a major excavation cost. The LHC was completed in 2008. In July 2012, it discovered the Higgs boson, the same particle the superconducting supercollider had been built to find. And CERN made the announcement on the 4th of July, an American holiday, which many physicists noted with a particular bitterness. Most physicists believe the Higgs would have been found in Texas, not Geneva, had the SSC been completed. $2 billion taxpayer dollars, 14 miles of empty tunnel, the most important scientific discovery of the century, made on another continent 2 decades later. Not every entry on this list is a highway or a subway. The Virginia-class nuclear attack submarine program was born from a crisis. In the 1990s, with the Cold War over, Congress had slashed defense spending aggressively. The Navy's prior submarine, the Seawolf class, was extraordinarily capable and extraordinarily expensive at nearly $3 billion per boat. Congress canceled the Seawolf program after just 3 submarines and ordered the Navy to develop something more affordable. The Virginia class was the answer. The original plan called for building 2 to 3 boats per year at a target cost of approximately $1.65 billion each. Congress approved the program in 1998. The first submarine, USS Virginia, was commissioned in 2004. Today, each Virginia-class submarine costs approximately $4.5 billion, a 139% increase from the original per-unit estimate. A 2024 Navy analysis found the program was more than $17 billion over budget in total. Production, which was supposed to reach 2 submarines per year, has averaged only 1.2 per year since 2022. The total accumulated schedule delay across all boats in production has exceeded 410 months. Only 2 shipyards in the United States can build nuclear-powered submarines, both operating as sole-source suppliers with no meaningful competition. When inflation hit post-pandemic supply chains, there was no alternate route. The costs absorbed directly into the program. The stakes are not abstract. The Navy's fleet of attack submarines underpins America's ability to project power, gather intelligence, and counter Chinese naval expansion across the Pacific. Under the AUKUS agreement, the U.S. committed to sell Virginia-class submarines to Australia starting in the 2030s, commitments that presuppose a production rate the program has never actually achieved. Each individual submarine is a genuine marvel. The men and women who crew them are among the most highly trained military personnel on Earth. None of that changes the arithmetic. A program $17 billion over budget, running at roughly half its target production rate, with an AUKUS commitment that requires delivering boats abroad while simultaneously growing the Navy's own fleet. The 2 per year production goal remains officially promised. It has been promised, revised, and re-promised for more than 2 decades. In 1999, a Georgia Tech graduate student named Ryan Gravel wrote a thesis proposing something radical for Atlanta. The city had a ring of abandoned freight railway that once encircled downtown. Gravel proposed converting it into something entirely different, a 22-mile loop of parks, trails, and light rail transit connecting 45 neighborhoods that Atlanta's Highway First development had spent decades dividing. The city adopted the idea in 2005. The promise was comprehensive: trails, green space, light rail transit running the full loop, and 5,600 units of affordable housing built or preserved along the corridor. Those three promises came true at very different rates. The trails were built. Today, the Beltline's East Side Trail is one of the most popular recreational corridors in the Southeast. More than $9 billion in private development has followed the Beltline's path. That development is precisely the problem. Home values within half a mile of the Beltline have risen 17 to 26% more than the rest of the city. Median rents along the East Side Trail have increased by more than half since the trail opened. The very neighborhoods the project was supposed to lift up have become some of the least affordable in Atlanta, as longtime residents were priced out by the investment the trails attracted. As of 2023, only 3,555 of the promised 5,600 affordable housing units had been completed, 63% of a goal supposed to be fully achieved by 2030. Early in the project, money earmarked for land acquisition went instead to infrastructure and marketing, triggering exactly the property value increases that made affordable land acquisition later nearly impossible. The project's own founder saw it coming. Ryan Gravel resigned from the Beltline Partnership Board in 2016, alongside community equity advocate Nathaniel Smith, writing that the project's housing commitments were being overwhelmed by the pace of displacement. A family priced out in 2015 cannot move back in 2023 when affordable units finally arrive. Displacement is not reversible, and the rail transit, the component Gravel had argued from the beginning was the actual point of the whole thing, has still not been built. The full rail loop has no funded construction timeline. What Atlanta has built is a beautiful park that has drawn billions in investment and made the city more livable for the people who can afford to live near it. What it promised was a park, a transit system, and an affordable city. Two of those three things are still missing. The two railroad tunnels running beneath the Hudson River between New Jersey and New York were built in 1910. More than 200,000 passengers travel through them on Amtrak and New Jersey Transit trains every weekday. They are the busiest rail corridor in the United States. They were also severely damaged by saltwater flooding during Hurricane Sandy in 2012. One tunnel must eventually be taken entirely out of service for years-long rehabilitation work. When that happens, the remaining tunnel will be able to carry less than half of current passenger volume, a crisis affecting the entire Northeast economy. The solution has a name: the Gateway Program. 2 new tunnels beneath the Hudson, plus new track and station capacity at Penn Station, restoring redundancy to the corridor and allowing the damaged tunnels to be repaired. Planning for Gateway began more than a decade ago. Progress has been painfully slow. The project's cost is currently estimated at approximately $16 billion. Responsibility for funding has been disputed between the federal government, New York, New Jersey, and Amtrak through multiple presidential administrations. The Obama administration supported it, the Trump administration blocked it, then partially reinstated support. The Biden administration approved billions in federal funding. The current political environment has introduced new uncertainty. Importantly, construction is not purely hypothetical. Preliminary and enabling work has begun at key locations, including concrete casing work at Hudson Yards in New York and earthwork in New Jersey. But the project remains years from full construction, and its federal funding picture is subject to ongoing political negotiation. Every year of delay costs approximately $1 billion in increased project cost as inflation is baked into revised estimates. The urgency is not hypothetical. The 1910 tunnels have already required emergency maintenance that temporarily reduced their capacity. Sandy's saltwater flooding corroded reinforcements now held together with interim repairs. When one tunnel must close for full rehabilitation, the capacity impact on the Northeast Corridor will be severe enough to affect the broader American economy. What makes Gateway different from most projects on this list is not what went wrong, it is what hasn't fully happened yet. No major contracts have failed, no machines have broken, but every year the project moves slowly. The cost estimate rises from $13 billion when detailed planning began to $16 billion today, while the tunnels beneath the river get older. The tunnels beneath the Hudson were built in 1910. In 2026, they remain the only rail connection between New York and the rest of the country. The Gateway program has been in planning for over a decade. The clock is running. Every project we've covered today began with a number. In most cases, that number was wrong from the moment it was announced, not because costs were genuinely unknown, but because a realistic figure would not have survived a public vote or a congressional appropriation. Optimistic numbers got projects approved. Accurate numbers would have killed them in committee. The problem is not that governments build ambitious things. Ambitious things are worth building. Highways and tunnels and rail systems and submarines are exactly what public money is supposed to fund. The problem is that the American public keeps being asked to approve one project and woken up years later to discover it has become something else entirely, something 3 times as expensive, a decade behind schedule, and often still incomplete. Until the optimism is priced out of the estimates, until the first number presented to the public is the honest one, the list will keep growing. Which of these projects do you think was the biggest waste of taxpayer money? Tell us in the comments. If you want to see what governments build when they get it right, check out our breakdown of the world's greatest megaprojects, where ambition and delivery actually matched. Subscribe to SIGNUM. More to come.